Uh, in this video, we'll look at some of the Pytorch functions, and yeah, just the aim of this video is just to show you some of the Pytorch functions and the corresponding NumPy functions, and kind of prove to you that Pytorch is just the same thing as NumPy but for deep learning. So it's optimized, can be optimized for GPU, and you working with tensors is better for if you're using deep learning, but it's nothing new. That's the aim. That's the point. It's nothing new. It's just like using NumPy. So I'll go to the PyTorch documentation. This is the PyTorch documentation. This is the first page, and we did the first portion of the tensors in the last video. I'll just read off the functions and do some good examples, good or like just a couple of examples, because this is also something I would like to like to show you is like reading of documentation, which is something you need. Also, most of these functions are not something I remember personally. So, for example, we did this first part creating ops. So we did torch.tensor converts the input element into object into a tensor, and this is the same function torch.as_tensor. This does the same thing. Then torch from numpy converts a numpy array into a torch tensor. Then we saw this torch.zeros has converts or creates a tensor of the given size filled with zeros. This is torch.zeros, like it converts takes input a tensor and creates another tensor filled with only zeros that has the same shape as the input. So there are uses for this. So then there's the same function that does torch.ones. Then there is the same function that does torch.ones like. Then we have torch.arrange. It is similar to np.arrange, which I'm sure all of you are familiar with. So let's take a look at that. We know np.arrange then gives us so the lower limit is 0 always. So if you do this, it still gives you that. But the lower, if you don't give a lower limit, it's assumed to be 0. Then the upper limit is 10, and has a step size of 1 right now. We could use a step size of 2. And similarly, we have a function in Pytorch called torch.arrange. So you have a lower bound of 0, upper bound of 10, and you have an array of tensors. Oh, from 0 to 9, you could probably have step size. Yeah. The thing is that this does not work with the lower bound. It does. It does. So yeah, it's exactly the same as the NP range. So nothing new here. And we also have torch.range. Uh, Linspace is something we use for plotting in NumPy. If you use that, torch.I creates an identity matrix. Torch.full, I believe, yeah, this fills the fills an array with a particular value. Like for example, if I have torch.full of size 10 comma 2, fill it with 7.456432. Okay, and it's a tensor of size 10 cross 2 filled with 7.432. Pretty sure we have a NumPy version of it. I don't remember exactly, but yeah, these were like simple, basic, and kind of important functions of uh, uh, PyTorch and similar functions in NumPy. Then another set of functions I want to look at is random sampling. These are functions corresponding to the NumPy.random set of group of functions. So it's exactly the same thing. They do the exact same thing. For example, let's try an example. Yeah, for example, like torch dot normal. Yeah, we could do torch dot normal. So torch dot normal, we have 10 or mean 1, standard deviation 1. Does it work? Huh. Okay. So it needs, so the input should be a float. The standard deviation needs to be a tensor, which I'm not sure why, but okay, let's let's say the mean is 0. The standard deviation is torch.tensor 2. Does it work? Needs to be a tensor. Yeah, so this is bothering me a little. Let's add a size element here. Hmm. Oh, so it expected a tensor here as well. Is that the case? Hmm. For example, let's say I copy this. This works, but what I did not work. Okay, so I have mean std is equal to size equal to 1 Huh. That is a bit strange. But if I do this, this works. Huh. Should work. Oh, okay. So I had a stupid bug, but this works. Okay, let's go ahead. For example, we have torch.poisson. It puts generates an element from the Poisson distribution. We have torch.rand. It returns a tensor filled with random numbers from uniform distribution. We have randint. Okay, let's try randint. I'm pretty sure we have, or let's try the NumPy version first. So it's pretty sure we have it by the same name, randint. Yeah, and then we have torch.randint, which gives me an error again. Oh, okay, I have to specify the size. Yeah, it's kind of particular about the size. Not sure why. Torch is really particular about the size, but yeah, looks okay. Yeah, so it generates a random number. Uh, but yeah, so basically this set of functions are the same as what goes on in NumPy.random. So I mean, I use NumPy.random a lot, and you could just instead use a NumPy torch.random and or set up these functions, and it will just do the same thing for you.